Hello everyone, welcome to this video. My name is Amir Senahari. I'm a Google Earth Engine expert. Today I'm going to show you how we can estimate the population of region of interest. If you are working on an urban area or if you are working on a rural area, there are some products in the Earth Engine helping you to estimate the population of that region since 1975 to 2030. And also it's very valuable product in the Earth Engine. So if you want to know more, let's go to the Earth Engine JavaScript code editor. So in the first step, we need to identify region of the interest. There are some products in the Earth Engine that helping you to find relative shapefile for your urban area or your region of interest. For example, in this tutorial, I'm going to show you how we can estimate the population of a province. For example, I want to select a province in my own country, capital of Iran. Tehran is my region of interest, but I don't have its shapefile and I don't know how to set the border of this urban region. So it's very simple through the FAO product to select the region of interest and then use the further processing based on the available shapefiles in the Earth Engine data catalog. So just first select your region of interest by the point-based geometry. Just I pin my region of interest by the available drawing tools here, and then make a new variable equals to, for example, the urban or target area, or simpler ROI, region of interest, equals to, through the search places and dataset, you can search through the Earth Engine data catalog and find your desired products. I want to search for FAO administrative borders. As you can see, some administrative unit layers available in country-based, country boundaries, first level administrative unit, and second level. The second level mostly useful for the urban areas, and the first level used to select each province. So I want to select the province including Tehran city. So import it into the code, and the next, for the ROI, we assign a table or import a table to the ROI here. And then using filter bound, I can filter it or only select the province including Tehran city through the filter bounds geometry. Next, through the map.add layer, we can see the filtered region of interest. As you can see, the province of Tehran in the north of Iran, including the capital, plotted successfully. So, and then in order to have focus on this region, I am using map.center object in the code for the ROI or region of interest. It's very simple and easy to use programming to select identify region of the interest without uploading any shapefile in the Earth Engine platform. You can use this kind of programming technique for selection of your study area based on the administrative border. So in the next step, I want to show you how we can get the population of the province that is already selected. So make a new variable, population equals to, through the search places and dataset, you can go to the browse data catalog to browse your desired product. Browse by tags, helping you to search the data based on the specific keywords. In the filter dataset tags, you can write some keywords relative to regarding to the population or desired satellites or sensor or whatever you want based on your application or based on the satellite or sensor. For example, I want to show you the Landsat derived product. It's a very, very valuable keyword in the Google Earth Engine platform that helping us to have a comprehensive access to all the products extracted from the Landsat data in variety of applications. So here, if you browse through the data set here, you will find something about the built-up and urban area. For example, here we have a product showing global built-up surface for the 30 years. But we don't want to only work on the urban area. Actually, the population of the urban area is very important for us. For example, GHSL is a kind of target name or a keyword that helping us to have access to all the products available for the all the products coming from Landsat and also created for the monitoring of urban areas, whether it is height, whether it is or global built-up surface or population surfaces. As you can see, GHSL product for the population is available here, and since 1975 to 2030 and developed by ECJRC, and also the bands is available. There is only one band with 100-meter spatial resolution that in which population count showing that the range of population, range of people who are living in each pixels. As you can see, it's showing the number of people living per pixel, and also it's very, very valuable estimation about the population, although this is not 100% correct, but in my experience it is very, very awesome product with a close estimation, and also we can rely to such kind of products for the human or population analysis. At least it was very perfect in the study areas that I have tested before. So, and also here there is a citation and DOIs, and also you can reference to this product or you can cite this data in your own papers or projects that you are working on. So just copy the name of product, GHSL. It's a very, very awesome product. Paste it into the search places and dataset. Global population surfaces is available. Import it into the code, and also here we have it as an image collection. Then assign image collection to population variable. And you don't need to set filter date and filter bound. It is available 5 years. For each 5 years, we have one population dataset for global. For example, here, if I print the population, you will see in the right panel the image collection characteristic. So run the code. In the right panel, you can see we have one population data set available since 1975 to 2030. Although we are in 2024 now, but 2025 and 2030, it is some sort of estimated or anticipated values for that years. And as you can see, for each years, we have one band naming as population count, showing the number of people living per pixel. So, and also we can do visualization process to get more insight about this product. Now you know that we have an image collection every 5 years, one element, one band, and showing the population count, the number of people per pixel. So now through the map.add layer, I can show you the visual characteristic of this data. For example, map.add layer, population. In order to have if you want to have all elements together through .2 bands, you can make a stack layer including all years. And then if you want to have only for the selected region, you should clip it based on the ROI or region of the interest that's already extracted from the FAO product. Leave visualization parameters empty, and the name is population. And to avoid automatic visualization or load of image, I set false at the end. Run the code again, and after a few moments you can see the population dataset is available here. So if you go to the data description, you can see for each 5 years with 5 years interval, we have one population dataset that's showing the number of people living per pixel. For example, this is for 1990, and then visualize it through 90% stretch. Click on apply. Here with more visualization, with better visualization, you can try other methods and also other kind of stretching techniques. As you can see, the darker region showing lower number of people living, and also the brighter region showing higher number of people living per pixel. And for example, here in the main part of Tehran city, the most populated region showed by the white color. Through the inspector, if you select, for example, if I touch one pixel here, you can see the number of people who are living in this pixel since 1975 to 2030. For example, in 1975, it was estimated that in this pixel, around 112 people are living. But it is anticipated by 2030, the number of people living per pixel in this region increased to 242. And also, it's very, very interesting product that helping us to get insight about the population of regions, and also make a connection between environmental analysis and also the population and number of people who are affecting in the critical situation. So for example, here you can see the plot of population changes in this pixel by the icons available here, and then you can download it with CSV format through here. It's very, very simple and easy to use. And now I want to show you in the next step how we can get the time series of population. For example, I want to get the sum of the people living in this region in the selected province since 1975 so far. It's very simple. Just we need to use a chart and get the sum of the population, the sum of the pixel values over the time. Type print user interface chart image.series, helping us to get the sum of the people living in this region. Image.series, couple of arguments available here, an image collection first replaced by population, and the region replaced by ROI, the province we are studying, and the reducer is very important. If you want to get the sum of or the total of population living in this region since 1975 so far, you need to use Earth engine.reducer.sum. And then a scale should be 100. It is very important to set a scale as 100 because the original spatial resolution for this product is 100 meter as it is described in the data description. In the bands, the resolution is 100 meters. Increasing or decreasing a spatial value or the scale value here leads to strict overestimation and underestimations in the final result. And if you want to use this product with the best accuracy, you should set a scale as 100. So, for example, if you reduce it from 100 to 1000, maybe you will have some underestimations. Or if you increase it from 100 to, for example, 10 meter, maybe you will face with some overestimations according to my experience and also the study area I have selected. So instead of X property, as this product including system time starts, X property equals to system time start. So chart is generating, and here you can see the variation of the population in my study area or Tehran province. For example, in 2015, the estimated population for the Tehran province is 14 million people, or more than 14 million, 14 and a half million people. So, or 500,000 people. And we can check it if it is true or not. Based on my experience of living in Tehran city, it's close to real value. But if we don't have information about the population of the selected region, you can only do a simple search in Google. For example, here I'm writing Tehran province population to see how much the population is. Based on Google information, the Tehran population or Tehran province is about 30 million people. And here you can see the estimation is the estimation for 2015 is 14 million people. It's really close. And also there is one more thing. The border that FAO that the border for Tehran province that presented by FAO is not updated. In the newest structure, or in the newest actually the border, we have a smaller region for the Tehran province. And also I think if I have the updated border for the selected region, maybe we will have more accurate estimations about the region that is selected. So it's very simple and easy to use product, and you can use it for all around the world. For example, I want to select another region in this study. For example, I want to select a part of one of the cities in the northern Iran. For example, here we have a Gilan province. Just I changed the pin from Tehran to Gilan in the north of Iran, and then I'm running the code, and here you can see that immediately the new border for this province drawn by the FAO product, and here you can see the trend of population since 1975 to 2030. For example, we can search it through the net to see how many people living in this region. Gilan province, population 2.5 million people according to the Google information living in this region in 2000 was living in this region in 2016. And when we checked our code, you can see that in 2015 around 2 million people were living in this region. That is really close estimations. Specifically for the historical data analysis, this is a very valuable product because most of the time we are facing with lack of enough data about different parameters. Such kind of products with a good estimation close to the real situation, helping us to have an assessment to see that how the environment, the people area or urban areas changing from the past so far, and also more importantly, it giving us a good insight about the changing for the future, and also it's very valuable things that you can use in your studies. And also I used this product before in some research work, and also I got a good estimations compared to the something reported by the Google. And now you can use these products in the Earth Engine, and its code is also available in my YouTube channel. And also I will be happy if you like and follow other YouTube videos that I have produced about the Google Earth Engine platform. If you had any problem regarding to the tutorial programming techniques, you can put your comments there. I will check and answer your questions. Thank you for your attention.